Hello everyone. In this video, we are going to understand one of the numerical based on the banker's algorithm. So in the previous video, we have already discussed about the banker's algorithm, and specifically we have talked about the safety and the resource request algorithm which are inside the banker's algorithm. So if you have not watched those videos, please watch those videos. You can find the link in the video description in the operating system playlist, or you can find the link here also in the I button. Okay. So this is the question based on the banker's algorithm again, and let's see how we can solve this. So we are given these three processes with their maximum needs and how many number of resources that are currently allocated with the help of this allocated. Okay. And we are given that currently we are available with these resources. That is, we have 3 instances of the R1 resource, 2 instances of the R2 resource, and 1 instance of the R3 resource. Okay. So again, this R1 can be printer, R2 can be your CD-ROMs, and R3 can be your tape drive. Okay. And we are asked a question that, let's say, if this scenario is given and the request of the P0 process comes, and P0 asks for some number of resources of the R1, R2, and R3. So it asks for the 0 number of resources of the R1. Okay. And it asks for only 1 instance of the R2 and only 1 instance of the R3. Okay. And the question is, if P0 asks for this number of resources, will that request, this P0 request, will be granted by the operating system or not? So as we have seen in the previous video, that to solve this question, first we should know what is the need matrix, or you can say what is the value of the need column. Okay, we have to find the need column. So this is the need value. Okay, so need, or you can say this is the future need or future need of the resources that this P0, P1, P2 can ask for. So here the maximum resources that it can ask for is 753, and the currently allocated are 010. So in the future, how many more resource can be asked by P0? So maximum minus allocated. This will give us 743. 7 minus 0, 7. 5 minus 1, 4. And 3 minus 0, 3. Same we will do for the P1 and P2 to find this need one. Okay. And here you can see the need or the future need of the P0 is 743. But currently it is asking for only 011. Okay. That means we are asking for a small amount of resources at current point of time. So the question is, will the OS grant this request or not? So as we have seen in the previous video, that this request will only be granted by the operating system if and only if after granting this request, the operating system see that the system will go into the safe state. If the system is going into the unsafe state after granting this request, then this request of the P0 will not be granted. Okay. So banker algorithm will do its background work and will see whether granting of this request leads to the safe state or unsafe state. Okay. So this algorithm we have already seen in the previous video, that is resource request algorithm. Okay. So let's solve this question. So first we have to check the two conditions, that P0 request should be less than equal to need, and P0 request should be less than equal to available number of resources. If both these conditions are true, then only we will proceed further. So here you can see the P0 request is 011, right? And the need of the P0 is 743. Okay. So we have to see that we should ask for lesser number of resources than our need. Okay. So our future need is, we will ask for, or the P0 will ask for 7 resource of R1, 4 resource of R2, and 3 resource of R3. But currently we can see P0 is asking for 011. So here you can see 0 is less than 7. Okay. So this condition for R1 is okay. 1 is less than 4. Okay. And 1 is less than 3. So that means this whole request thing is less than need. Okay. Now request is less than available. Let's check. So request is this, available is this. So 0 is less than 3. Okay. 1 is less than 2. Yes. And 1 is equal to 1. Right. So here it is actually equal. 1 is equal to 1. Okay. So this is actually less than equal to 3 to 1. So first condition and the second condition, both are true. Okay, so will it mean that we will grant the request of the P0? No, actually we cannot say confidently that we will grant the request of the P0. Why? Because after granting the request, we have to see whether our system will go into the safe state or not. So what does it mean? So as we have discussed in the previous video, we have to first find the values of this available, allocated, and the need. Okay, and after that we will proceed with the safety algorithm. Okay, so as OS is pretending that it is giving the 0, 1, 1 resource to the P0. Okay, so what does it mean? So let's say if OS say okay 0, 1, 1 is granted to P0, that means the more number of resources will be allocated to P0 and need will be reduced, and this available one will also reduce. So that means if 0, 1, 1 these resources are given, that how many resources we are left with? So 1 minus 1 0, 2 minus 1 1, and this 3 3 1 0. Okay, 3 1 0. These are the available resources now after granting the request of the 0, 1, 1. Okay, you have to be very careful that we are pretending. Okay, we are doing the background work. Actually this P0 request is not granted as of now. Okay, it will be granted only after the safety algorithm will say if it is a safe state or not. Okay, so let's say we pretend 0, 1, 1 is given, then available will be 3, 1, 0. Now if 0, 1, 1 is given, then it will be added with the allocated one. Okay, so it will be like allocated, so it will be added. So I am writing here 0, 1, 0 was the previous allocated. Now currently we are giving 0, 1, 1. So it will be 1, 2 and 0 is like 0. Okay, so 0, 2, 1. These are the allocated number of resources now. Okay, they have increased. Now when we have given this request 0, 1, 1, we have granted this request, then our future need will reduce. Okay, because we have now given 0, 1, 1. Okay, so it will be like we have to subtract 0, 1, 1 from 743 to find the leftover future need. Okay, 3 minus 1 2, 4 minus 1 3, and 7 7 comma 3 comma 2. This will be the future need. Okay, okay, so this is our new values of the allocated, available, and the need. Okay, now let's update these values. So here I have updated all the values of the allocated, need, and the available one. Okay, so now we have to apply the safety algorithm. So what does it mean? So we have to now see that after granting the request, this is the state of our system. Now this state of our system represent the safe state or not. We have to find this. If after applying the safety algorithm we got to know that yes, we can find any safe sequence. Okay, we can find any safe sequence, then it will mean that we are going into a safe state. Then in actually the request of the P0 of 0, 1, 1 will be granted actually. Okay, but if we do not get any safe sequence, that means we will go into an unsafe state. Then in actual 0, 1, 1 request of the P0 will not be granted. It will be denied by the operating system. Okay, so let's apply the safety algorithm, and again we have seen this in the previous video. Okay, so in the safety algorithm we have the work array, we have the finish array. Work array will be initialized to the available array. So available has the number of resources 310, so it will be 310. Finish array will be equal to how many number of processes are there. So we have how many number of resources. Here you can see we have 3 resources, and how many number of processes we have 3. Okay, so it will be actually 3, not 5. Okay, so finish array will be equal to total number of processes. Okay, 1, 2, and 3 processes. Okay, now we have to proceed with the all the processes, and we have to see whether we are able to satisfy their need or not. Okay, so this is the 0th process, this is the 1st, this is the 2nd, and now let's start with the I. Okay, so we'll start with the P0. So at I equal to 0 we have to see its need. Okay, so first we have to see whether this process is completed or not. So P0 is currently not completed, that means its need is not fulfilled as of now. So here you can see this is our finish array. Okay, and currently it is false. Okay, this is the same finish array. So this finish of 0 is false. Okay, that means this is not finished as of now. So okay, so let's see. This need is less than your available number of resources in your system. So here you can see this 732 is actually not less than equal to 310. Okay, this is actually greater than your available. How? So 732 is the need and available is 310. Okay, 7 is greater than 3, right? And 3 is also greater than 1, 2 is also greater than 0. So it is actually greater than your 310 that is available. Okay, so you can say available, or you can say work. Okay, or like you can say initially work and available are same. Okay, so okay, we'll go with the work. Okay, so your need is greater than work. So when these conditions are true, then only we will proceed further. But here this one condition, this need condition is false, so we will not proceed further because we are asking for more number of resources than the currently available one. Okay, so what we will do, we will leave this I equal to 0 and we will say okay, just check if we can grant the request of the P1. Okay, so now let's start with the I equal to 1, and here we will see that both the conditions are true. The finish of this 1th process, that is P1, is false. Okay, the need of this process is actually less than 1. So need is 010, this is the 010, and work is this one. Okay, 310. So 0 is less than 3, 1 is equal to 1. Okay, we can go for equal to also, and 0 is equal to 0. So this is less than equal to 310. Okay, so that means we can go with the next step. So this work, as we have seen in the previous video, it is equal to, this is the current work plus allocated 1. So how many resources are allocated? 302. So we will add and it will become 612. That means after we grant the request 010 to P1, and after that it will release all the resources, then finally we will have 612 after P1 releases all the resources. Okay, and the finish of this will become as true, right? Okay, now let's go with the P2 and check if we can satisfy this need with this number of resources or not. Okay, so at I equal to 2, if we see, this is the, you can say, need. Okay, this is the need, and work is updated to 612. Okay, so here you can see this process is also not completed, so this is actually 2. Okay, this is actually 2. So finish of 2 is false. Okay, so if we check this need, now the second condition, that means okay, 6 is less than equal to 6. 6 is equal to 6. Okay, 0 is less than 1. Yes. 0 is less than 2. Yes. That means this total is less than equal to 612. My condition is satisfied. Both these conditions are satisfied. Okay, so grant the request and after some time release the resource. What does it mean? We have to see work equal to work plus allocated. Okay, so for P2 allocated is 302. So 6 plus 3, 9, 1, and then 2 plus 2, 4, 914. Okay, so these are the, you can say, available number of resources, okay, in our computer system after we grant the request of P2 and it releases the resources. Okay, and finish of 2 is true. So this process P1 and P2 have been completed. That means I have granted the request of the P1 and P2. Okay, now again we have to go with the P0 again because it is not yet completed. Its need has not been completed. Okay, so now let's again go with I equal to 0 and see finish of 0 is false. That is okay, but again need of P0 is actually greater than your work. Work means available number of sources are 914, and the need is 732. So actually if we see, 7 is actually less than 9. That is okay, but 3 is actually greater than 1. That means for R2 resource, okay, we are asking for 3 instances, but we have only 1 instance of the R2. So actually this condition will be treated as greater than. Okay, need is greater than work. Okay, all the 3 should be less than equal to this, all the 3. Okay, but if any of the thing is like greater than your work, okay, then we'll see this relation is you can say unsatisfied. Need is greater than work. Okay, so we will not proceed further. That means we cannot grant the request, or we cannot grant the future need. Okay, of the P0. Okay, and P1 and P2 are like completed. So we are stuck. First, we completed the request of the P1. Okay, then we completed the request of the P2. V means operating system. Okay, then operating system check that it cannot complete the request of the 0th process, that is the P0. Okay, that means after this we are not able to write P0. Okay, because its request cannot be granted. That means we cannot get any safe sequence. Okay, because P0 cannot be written here. Okay, so that means there is no safe sequence. Okay, that means there is no order of processes in which we can complete the request of each and every process. That means we will go into the deadlock situation. Okay, that means if we grant the request of the P0, which was 011, okay, P0 asks for the 011, request for the 011. So if we grant the request of the 011, we will go to this state, and in this state we are not able to find the safe sequence. That means this is a unsafe state. Okay, so OS will say I will not grant the request of the P0 in actual. So that means we have got into a danger situation. So there is no safe sequence possible. That means we are gone into the unsafe state. That means OS will not grant the request of the P0. That is 011 will be denied. Okay. So I hope you have understood this question, that how we solve this question. And if you have not understood any of the things, you can watch the previous videos also of this numerical, or you can say of this banker's algorithm. Okay. And again, if you have not understood any of the things, you can write down into the comment box your queries. I will solve them. So if you like the video, please like and share this video among a friend also, and please subscribe to the channel and press the bell icon for further notification. See you in the next video. Till then, goodbye.